Hey guys, we're going to be taking a look at the 2002 AP Physics C Mechanics Free Response question. It's the first question, and it has to do with momentum and impulse. So the question is, a crash test car of mass 1000 kilograms, moving at a constant speed of 12 meters per second, collides completely inelastically with an object of mass m at time t equals 0. The object was initially at rest. The speed v in meters per second of the car object system after the collision is given as a function of t in seconds by the expression v equals 8 over 1 plus 5t. So part A asks us to calculate the mass m of the object, but first here is how the scenario looks. So the car, 1000 kilograms, is traveling constant speed 12 meters per second towards the mass m, and at t equals 0 it collides with the object mass m, and individually the car has an negative acceleration while the object has a positive acceleration, but as a unit they have a constant speed v. So part A, calculate mass m of the object. First we start off saying that the initial momentum is equal to the final momentum. So mvi equals m plus mv final, the mass of the car and its initial speed is equal to both masses combined times their final speed. And here is when we plug in the numbers. 1000 kilograms was the weight of the car given in the problem, and its constant speed of 12 miles an hour. And then we have the mass of the object m plus the mass of the car, which is 1000 kilograms. And then we just use the equation they gave us, which is 8 over 1 plus 5t meters per second. And you put in at time equals 0, because that's when the initial collision happened, time equals 0. So we just plug that in, and we get that the final velocity was 8 meters per second, I'm sorry. And we rearrange the equation over here, and we end up getting that mass m of the object is 500 kilograms. For part B, it reads, assuming an initial position of x equals 0, determine an expression for the position of the car object system after the collision as a function of time t. So here we know that velocity is a derivative of x position, and acceleration is the derivative of velocity, so you can see here, and it goes both ways. So velocity is the integral of acceleration, and x position is the integral of velocity. So we're given the velocity, it's an equation 8, which is right here. So we just take the integral of that to get the position, and we have to make a u substitution in order to do this. We make u equal 1 plus 5t, and du is 5 dt. Then we plug it back in. Then we're able to integrate this. We get x equals 8 over 5 ln u plus c, and we're able to take out the absolute value bars, since time's always going to be positive, and we get this equation, and we're able to take out c, because at time 0 position is equal 0, which means that c needs to be 0 in order to make this work. So our final equation for the position is x equals 8 over 5 ln of 1 plus 5t. Part C says determine an expression for the resisting force on the car object system after the collision as a function of time t. So obviously we know that F equals ma. It's total mass to give us the total force. And again, acceleration is the derivative of velocity. Velocity is the equation they gave us. So this time we need to take the derivative of the equation, which is simple enough. Take the derivative, few math steps, and we end up getting that the derivative is negative 40 over 1 plus 5t squared. And that is the acceleration. So we have the acceleration, and we also have the total mass. Since the total mass is just the car plus the object, and we were able to find the mass of the object before, which is 500 kilograms, we just add them up. So our total mass is 1,500 kilograms. Then we just multiply these two things, our acceleration by our mass, and we get an equation for force. Negative 6,000 over 1 plus 5t squared is our equation for force. Then the final part, part D, is to determine the impulse delivered to the car object system from t equals 0 to t equals 2 seconds. We know that impulse is equal to delta momentum, which is equal to the mass times the average velocity, and average velocity is just v final minus v initial, and so our final velocity is at 2 seconds. We have the equation for velocity